Hey guys, so today what we're going to do is we're going to combine a lot of the skills that we've already learned to this point, including writing and balancing chemical equations and doing mass to mole and mole to mole conversions into a single skill of stoichiometry, where we are going to predict the amount of products that can be produced through a chemical reaction. In order to do this, we're going to focus on some practice problems. So let's get to the first one. So let's try the first practice problem. Now the first practice problem that we're given is going to be the synthesis of ammonia from nitrogen and hydrogen. And the first thing we need to do is write the unbalanced chemical reaction. Remember, nitrogen and hydrogen, when they're all by themselves, are diatomic, which means it's N2 and H2. We now need to balance this chemical reaction. The way we're going to do this is we are going to add a 3 in front of the hydrogen and a 2 in front of the ammonia. If you need to review how to balance chemical equations, you can go back to that video in particular to give yourself a quick refresher. The reason we need to balance chemical equations is because what we need to do to solve a problem is understand that there's a mole ratio, and we're going to get to that here in a second. So in order to see what that mole ratio is, the chemical equation needs to be balanced. So we're just going to start with what we're given, which is 112 grams of nitrogen. We want to convert from that into grams of ammonia, but there are going to be a couple of steps between the first and the second. So what we're going to do is we're going to start by trying to get into moles, because moles are kind of the common theme and the common language, if you will, of the chemical equation. So in order to get into moles, we're going to divide by the molar mass of nitrogen. This is where it becomes very important that you do not lose your units. Always write your units, because when we're dividing by the molar mass of nitrogen, it's not just N. It's N2, which means we have to divide by the molar mass of 2 nitrogens, which is in fact 28 grams per mole. Once we're in moles of nitrogen, we can convert into moles of ammonia. The way we do this is simply by using the mole ratio. The mole ratio of nitrogen to ammonia is 1 mole of nitrogen to 2 moles of ammonia. Because we want to cancel the moles of nitrogen, that's going to go on the bottom. Again, this is where it becomes very important to make sure you keep your units. This way you know what you're dealing with. We're in moles of ammonia, we want grams of ammonia, and to get from one to the next, what we simply have to do is multiply by the molar mass of ammonia, which is 17 grams per mole. Now at the end of this problem, all we're going to do is multiply across the top and divide across the bottom, and the way it's going to end up working is units are going to cancel to give us what we need. Grams of nitrogen are going to cancel, moles of nitrogen are going to cancel, moles of ammonia are going to cancel, and we're going to be left with grams of ammonia. Now the answer to this problem is that we result in 136 grams of ammonia produced, which means that we have 136 grams of ammonia that can be produced from 112 grams of nitrogen that we start with, assuming that we have excess hydrogen. Alright, let's try a second problem. In this second problem, what we're going to do is we're going to change things up a little bit. We're going to find the amount of reactant needed as opposed to the amount of product that can be produced. Always we start with the unbalanced chemical equation. Just so you know, the thiosulfate ion is not one that you need to know, but it is one that we might come across here and there in AP chemistry. So it's a good one to kind of have in your back pocket should you ever see it. So there's our chemical equation. We now need to balance the chemical equation. We're going to do that by adding a 2 in front of the silver bromide and a 2 in front of the sodium bromide. In this case, just like in any other, we're going to start with what we're given. And in this case, we're given that we have 42.7 grams of silver bromide. We want to convert from grams of silver bromide into grams of sodium thiosulfate. And in order to do that, we first need to go from grams of silver bromide into moles of silver bromide. We do this by dividing by the molar mass of silver bromide, which is 187.77 grams per mole. To convert into moles of the sodium thiosulfate, we need to then use the mole ratio. 2 moles of silver bromide for every 1 mole of sodium thiosulfate. And finally, we need to go into grams of sodium thiosulfate, and we do this by multiplying by the molar mass of sodium thiosulfate, which is 158.11 grams per mole. Okay. So as you can see, we've multiplied by the molar mass of sodium thiosulfate. So we start with what we're given, and we can cancel out every unit up through that final one. So we cancel grams of silver bromide, we cancel moles of silver bromide, we cancel moles of sodium thiosulfate, and we're resulting in grams of sodium thiosulfate. You multiply across the top, you divide across the bottom, and what we end up with is an answer of 18 grams of sodium thiosulfate. So this is the amount of sodium thiosulfate that we need to react successfully and completely with 42.7 grams of silver bromide. Now we're going to do a third problem. In this problem, I want you to try it kind of on your own. And we're going to be looking here at a combustion reaction, and I want you to try solving this problem on your own. All right, so take a few seconds, pause the video, take a look at this problem, and I want you to solve it as best as you can. I'll come back in a second and I'll explain how you do it. So for this problem that we just solved, all right, hopefully you guys got to an answer. If you didn't, that's okay, because I'm going to go through it with you now. So again, just as we did in the prior problems, we're going to start with a chemical equation. In this case, for a combustion equation of methane, we have CH4, which is methane, plus oxygen, which react to yield two things. With every combustion analysis, we produce water, and we produce carbon dioxide. We need to balance this chemical reaction. All right? If you need to remember how to balance chemical reactions, again, you can go back and look at the balancing equations video. But in this case, we're going to end up with a 2 in front of the oxygen and a 2 in front of the water. So now our chemical equation is balanced. So we have a balanced chemical equation here. And again, we're going to start with a value that's given to us. In this case, we have 48 grams of methane. Let's go ahead and start by solving for the amount of carbon dioxide that can be produced through this chemical reaction. First thing we have to do is convert from grams of methane into moles of methane. Remember, moles are going to be our common language in the chemical equation. The molar mass of methane is 16 grams for every 1 mole. Now we're going to utilize our mole ratio to convert to moles of carbon dioxide. And finally, we're going to convert from moles of carbon dioxide into grams of carbon dioxide. This leaves us with our answer, which is that we are going to be able to produce 132 grams of carbon dioxide. With water, we're going to go through the exact same method, so I won't talk you through it. We'll just solve together. And the answer to this is going to be 108 grams of water can be produced. So here we have our combustion analysis, where we have produced 132 grams of carbon dioxide, 108 grams of water, both from 48 grams of methane to start. All right, so that wraps up this video. So today, through a bunch of practice problems, we learned how to predict the amount of products that can be produced through a chemical reaction using stoichiometry. Stoichiometry, remember, is one of the best skills you're going to have in chemistry this year, and we're going to use it over and over and over again throughout the year. So make sure that you take plenty of time to practice this skill. I'd like to thank Megan Lamb, Justin Lowe, and Larry Shue for their contributions to this video. They wrote the script, directed and filmed, and did the post-production editing. Thank you guys so much for watching. I'll see you in the next video.